Okay guys, this is another overview video. Another thing that's pretty popular, see here we are, we're in class 4, so I'm going to kind of cover slope field related rates, tangent line approximation type problems. We're talking 7, 8, 9. So if I go over here and I filter on 7, 8, and 9, so 9 is tangent line approximation. Okay, tangent line approximation. So you can see it shows up a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me filter on just 9. So you can see 2012, there were 2 in 2013, there was 1 in 2014, 2 in 2015, 2 in 2016, 1 in 2017, 1 in 2018. For some reason, 1 didn't show up last year in 2019, but it's a pretty popular type of problem, equation of a tangent line approximation type problems. So what I've done is I've taken every tangent line approximation problem back through 2012 and I put them in this document here so you can see what they look like. Hopefully you get used to the wording, but these are typical tangent line problems that have been used throughout the years with their solutions. They're usually only worth 2 points. They're not heavy hitters, but it's 2 pretty easy points. Sometimes they come right out and say well, actually they always do. They come right out and say to write the equation of a tangent line. Every problem is going to say that. Write an equation for the tangent line. It's going to look like that every time. When you see those words, hopefully you think point slope form of the equation. Y minus y1 equals mx minus x1. Rearrange it just slightly to get y by itself. It's y equals y1 plus mx minus x1. M is the slope. It's the first derivative evaluated at x of 1. So it's the first derivative evaluated when x equals x of 1. And y of 1 equals f of x of 1. It's the value of the function when x equals x of 1. Sometimes they give you x1, y1. Sometimes they give you x1 and you got to find y1. So here it comes right out and tell you, write an equation of the tangent line when x equals negative 3. You've got part A of this problem had you find the first derivative. So you plug negative 3 in to find the first derivative. You plug negative 3 into the function to find y1. You write the equation of the tangent line. Okay. Here's a little bit of an extra thing. This one ended up being worth 3 points. Write an equation for the tangent line to the graph of f at the point 1, 0. So here they give you x1 is 1, y1 is 0. So they give you a differential equation. It's got x and y mixed in. So you plug 1 in for x, 0 in for y. You get that's negative 3. So y minus y1 happens to be 0. So y equals m times x minus x, 0. 2 points, typical. But then, guys, they ask you to use that tangent line approximation to approximate that. All that means is plug 1.2 in for x into your approximation. It's pretty simple. It's worth a point. So, guys, you'll see, you can scroll through these, write the equation for a tangent line, use it to approximate that, very similar to the one before. There's a mix of x and y's here. This actually is one I went through in Monday's class. Here's 2015. Again, they tell you x1 is negative 1, y1 is 1. I'm sorry, I'm in the wrong place. Write an equation for the tangent line to the curve at the point negative 1, 1. So that's x1, that's y1. You plug them in to find the slope. So there it is. Y1 is 1. So when you move it to the other side, you get that plus 1. Here it goes again. Write an equation for the tangent line, use it to approximate that. They cheaped out here. They only gave you 1 point for the tangent line, 1 point for the approximation instead of 3 points total. So again, find the derivative, write the equation of the tangent line, plug in 2.1 to find the approximation. Here, let's see, write an equation for the tangent line. This got a little bit tricky. It came from here. You had to use the chain rule, which was tricky. That's why they gave you 2 points to find the slope, because you had to use the chain rule in this table. That's a pretty popular problem. We gave you that as a multiple choice question in a test earlier in the year. And then you write the tangent line. Here's the boiled potato problem. They actually asked for the equation of a tangent line early on. Again, they gave you that's x of 1 is 0. H of 0, which is y of 1, is 91. Sorry. Yeah, 91. So you can get the equation of the tangent line. You plug in 91 for the initial temperature of the potato. Here's 2018, back to doing a tangent line approximation, and that's it. So guys, it's a pretty popular problem. It's not a heavy hitter, but that's what it looks like. So be ready for it. You've been seeing it in the free responses we've been doing. You're going to keep seeing it. I'll go through the 2 free responses for today's class next.